Yay, we're gonna program for the first time in weeks. Isn't that exciting? Hello, by the way. Ooh, almost made a mistake. I was ready to switch the scene, and then I realized the stream hasn't started. So I had to start the stream first. Which makes total sense, but I just, for some reason, forgot to start the stream. I was streaming without streaming. Oh well. Yeah. So last time we didn't find the perfect solution, but from what I remember, we did get a solution that kind of works, or at least seems to get the right results. I said I would like to just make a demo system just to try the different algorithms a bit more easier, but I'm gonna skip that. I'm just gonna implement something and see how it works out. Because I need to do some coding again. And the solution worked, sort of, while still keeping loops in our tree. So instead of a tree, we have a graph. We have a possibility for a tree, but that's unlikely. Usually we'll have some graph because the nodes can point to other nodes that point to them directly or indirectly. And the solution was to isolate the loops in our graph and then treat the quote-unquote normal parts of the graph that correspond to a regular tree, like the normal tree, and calculate scores for nodes inside a loop, specifically through an algorithm that looks only at that loop. So first order of business will be to isolate the loops in our graph. Yeah, that should be it. Where do we put the algorithm though? Should we maybe... It might make sense to find these loops while generating the tree, since we already have a lookup that lets us know we know this node. I mean, we already have a dictionary right now, or hash set. Wait, what would we do? No, this was a dictionary, all right. Set a node, yep. So we have a dictionary to look stuff up already, and that might allow us to figure out if we are part of a loop. But then again, it's... Well, I mean, if this is true, that means we have found a state that existed before. So we know the node we're coming from and the node we're going to are definitely part of a loop, right? Is that a guarantee though? I'm wondering if I can put that as a guarantee. Maybe I should just ignore that. Maybe I should... Let's keep the calculate score aside for now, or maybe not. Wait, what did I do here? Process nodes by state. This was just to keep track of which ones need... Alright, we can ignore that. So we have the full map of nodes, which is our dictionary. Nodes process will be empty. We could reuse that stack if we need to. Initial node will be the initial node, that's correct. That's gonna be the root, always. Alright, so we can rely on nodes and initial node. Alright, finding loops. What do we have to consider? Loops can merge with each other, in which case they all belong to the same overarching group that we should extract for one analysis, like in our example. But I can have independent loops, so I definitely do need some list or collection of some kind that contains several loops. And how do we store that? Should we... Let's see, a node can always only be part of one of such groups. Because if the node is part of a loop and another loop points to that node, that means that other loop can be still reached from this node. It's not an exit. I can't go back, that's not... Yeah, okay. So each node is only part of one loop group. Let's just call it group. We could store that information in the nodes themselves, like a simple marker, like an index. I am index so-and-so in this group of loops. And then just using that index, we can compare if a certain node has a certain ID, then we just find all its children that have the same ID and we know which nodes are in that loop. That means only an index we have to add to the existing nodes. Is that useful? We will need to make calculations within the loop directly. Where it might be easier if we just have... What if we make entirely new structures? No, wait. I've already started using score as a score value inside the node. Oh wait, we changed that as well, right? Instead of a single score, I had the ratio, the different win and lose conditions. Okay, let's start with that. That's something that I can do directly, that's easy. Actually, did I use classes for this? Yeah. Let's make a public struct score. And that will be... Let's make a counter, public int. Yeah, I have no idea how big those numbers can get. Let's keep it at int. Public int wins. Losses. And let's just comment it out, but potentially draws. Like we could add that later. Depends if we want to include that in the strategy though. That's... I forgot to look up the rules. I knew I forgot something. I haven't done my homework, I guess. Alright, let's forget about draw for now. Let's pretend there is no draw. Everything is running until one person loses. And if that takes forever, then maybe one turn more. Let's see, that's fine. We start with the 0, 0. Let's make some convenience functions. Just to have something easy to get programming again. The easy stuff first, and the complicated stuff later. What do we need? We need to combine scores. We need to add something to a score. Would we... Now we have value types. We create entirely new values, right? Actually, why is the mixer is pretty high on the volume right now. Is my volume too high? Have I put the microphone too? Let's see how... maybe this is why. Let's put the microphone further back. Yeah, that's a bit better. I'm talking at the screen right now, so the microphone needs to be repositioned from last time, where it was trying to listen to me talking into my desk. Okay. I mean, the simple method would be just a simple score at score A, score B, set B, and let's make a constructor public score that. Let's do that. And it's a new score. A dot wins plus B dot wins and A dot losses plus B dot losses. Let's see, what was... I'm trying to remember the syntax for operator overload. Public, static... Was it operator already? Or was it overload operator? Override. Take. Sure. Plus. Ah, wait. Score. Is this correct? Wait, can't do that. And this should also be static. Although in this case, let's just replace the old method. Gonna call it anyway. That seems to be the right syntax. Good. Hooray, I remembered it. I tend to mix up the specifics. I always mix up the operator overloads with the casting overloads, like implicit, explicit. Alright, we have plus, and what do we need? What do we need? What do we need? The comparison. Which score is... Yeah, no, let's just do an eye comparable. That's fine. Score, and let's just put that in here. Actually, let's do an eye equatable as well. Although, equatable, it's gonna be a bit weird. Nah, let's just use an eye comparable. And actually, let's change this. How do we evaluate wins and losses? I mean, of course, more wins than losses. Yeah, that's what we want. If... Oh. What's going on? Oh, keyword layout changed. Yeah, that's better. If wins... Okay, let's make a public bool winning score. Wins greater losses. And we can do the reverse, losing score. New score? Yeah. Losses 2s, losing 2 O's. Because that makes total sense. Right, if winning score. Okay, let's write it out completely first and then optimize, and not other dot winning score and minus 1. Not actually 1. Okay, if we went to write out the compare to, that means we're comparing us to other. So we are the first argument. And if we want to be the greater score, yeah. Greater score, we must be the winning one. Sure, this works. Okay, that's an easy case. I should maybe specify a few things more. Can I simplify things a bit more, actually? Right. The comparison has two base layers. We have first a general idea of, is this generally winning or losing score? And we can compare based on that. So is it winning, is it losing? Or are they both equal in that sense? If not winning score and other dot winning score per -1, yeah. Okay, easy cases where only one of them is winning bet. In that case, yeah, we go directly for that. All other cases. Actually, the ratio is kind of important to us, so maybe we can simplify it in that way. So we give just two values. Ratio or ratio. Let's just use the difference. Wins minus losses. And other ratio is other dot wins minus other dot losses. Okay, let's just use the difference, and then our ratio compared to other ratio. General comparison. Yeah, that should actually be enough. If general comparison is not equal 0, so if there is a difference in terms of just... Although... Oh, that's an interesting question. Let's say one is 1 guaranteed win and 2 guaranteed losses. And another case is 10 wins and 11 losses. In both cases we have 1 loss extra. But the one with the higher score has, at least in theory, more wiggle room. Like, there's presumably gonna be a lot more in terms of options, so the chances for the opponent to make a mistake are technically higher. How do we quantify that? Like, so having an absolute number of options is... No. Like, if the... No, that doesn't make sense. And with that argument, it is basically just we compare the... Not the difference between the two, but the actual ratio, like the original score we calculated. This isn't ratio directly, this is more like the difference. We can call it ratio. I'm wondering, does this... Why is it other wins? That was... Let's do it this way. Let's get rid of those two. And rename this. It's the other ratio. That wins. Like that. All right. Our ratio is how many wins. Okay, special case. If wins and losses are both 0, that would be a special case, in which case... Can't evaluate. Doesn't that even make... We should make that -1 then. Okay, let's write this out. Our total end states. End states. Was it complaining about this? Okay, autocorrect wants to end states better that way. Autocorrect sees as states in there. Right, and let's put this in here as well. That's other total and states is and states greater than 0, then that, otherwise let's use -1. And other total end states greater than 0, this or else end states. Yeah, so we don't get division by 0, and that should be a -1. If the score for some reason doesn't exist, which shouldn't happen, since we calculate from bottom up, it will just use a -1, which is pretty bad score. So an invalid node basically is considered very, very bad and always a loss. Unless the other one is also very, very bad and a loss because it's invalid, in which case we make the more detailed breakdown here. How would that look? The ratio is the same. Okay, guys, then we want to have in both cases the same ratio. If it's in our favor, we want to have less end states. And if it's in the opponent's favor, we want to have more possible end states, which indicates more decisions where the opponent might make a mistake. So ratio is the same. The ratio is the same. Can we just... Oh wait, I should... let's... Let's use floats in here. What? Floating point comparison. Unlikely that the ratio matches, even if it's logically the same, just because of rounding errors. They shouldn't be happening in our... Yeah, no, actually. I could make this a bit more accurate. Let's ignore that. How could I... You know, I'm wondering if I should just... You know what? We're not doing this with floating points. We're doing this a bit differently. So I'm thinking, if I don't want to use floating points, well, essentially what I have here is two integer numbers in a fraction. So what I do here is compare two fractions. Right now I calculate this to an actual fraction between 0 and 1. But I could just multiply both wins with the other's total states. And that way I get two, what's the English term? Denominators? No. Numerators? Numerators. Denominators was the one below, right? Non scalar, numerators, denominators, and numerators. Yeah, that should be the equivalent. So multiply both sides, or both of them with the other's denominator, and then we can directly compare those values. Also means no division anymore. And then int polar score is wins times other total end states, and other score is other dot wins times our total end states. And we can skip that and just compare our score with other score. No rounding errors anymore. Like, very much like. Hopefully the numbers don't get too crazy. In that case, we would have to adjust this a bit. I mean, the numbers will go big. I just don't know how big. We're talking just about million of states, or if we're talking about quadrillions, depending on the answer. I mean, since we allow loops, the total amount of actual end states should be a bit smaller. There's still a lot of, I mean, there's exponential growth here in terms of possible end states, even with the loops. So, don't know. We'll see. Can test that at that point. So at this point, if it's comparison to equal, that means we are exactly equal. No rounding errors. It is exactly equal. Perfect ratio. Equivalence. And in that case, perfect ratio, equivalence, both are exactly the same. And we're to compare if actually, what do we do in a perfect equivalence? Both are equal. What's in there? I guess in that case we would also... Okay, let's treat equal score between wins and losses as overwhelming losses. Or the same as losses. We want to have less chances, no, more chances for the opponent to make a mistake. Yeah. If wins are greater than losses, it means the ratio is in our favor. So it's a score of greater than 0.5. If we were to calculate it as an actual score value. And in that case, we compare the totals. And that is that compared to United States. Total states comparison like that, and do we need to do something? If that is the same, then we actually have the exact same values on both ends too, right? The total distance. Yeah, in that case we can just return the comparison. just we would have to invert it now, since in case of wins outweigh the losses, we want to have less total states. So the smaller value is preferable. So we have to invert this, yeah. And in all the other cases, we just compare, we want more states. The bigger value. This should be it. So this should be the comparison we want. And let's change this to score. Yeah, calculate score. Doesn't matter. Right. Right, score. How do we mark an invalid score? Just 2 negative values? Or it's just 2 zeros? It should be enough, right? This new score. New score will just be 2 zeros, which is like bool. Let's just call empty, or is empty. Wins plus losses. That's all equal to 0. Why? Doing the addition instead of 2 comparisons because it's faster, in theory. Actually, is it? I mean, it depends on what comparison I do, right? If I just make the comparison once, and comparison itself isn't faster. It's just that right now I have the addition and a comparison, and otherwise I would have one comparison, another comparison, and then a Boolean operation, 3 operations. And if I do the default and, would even have a branching pattern. Yeah, I mean, doesn't matter. So actually this kind of, now I can't do this. If I suddenly add negative values, I would, let's rename this to is valid. Wins must be greater, no. Okay, now I actually going down a path of why bother. But technically for valid score, both values need to be at least 0, and one of them, at least one of them, needs to be greater than 0. So if either of them is negative, or both of them are 0, it's an invalid score. And just adding the 2 can hide a negative value. If one is -1, the other is 1. Or let's say one is -1, the other is 2. Suddenly you have a positive score. Can't do that. So wins must be greater than 0, and losses, no, greater or equal to 0. Losses must be greater or equal to 0, and wins plus, okay, that one can stay then. Must be greater than 0. It suggests pattern matching, but I'm not. Well, actually, is it? Okay, am I done? This should be. Oh, yeah, of course. It's not the logical AND anymore, it's the Boolean operation. It could be a bitwise operation I'm doing here. But, I mean, it is a bitwise operation. And before I was able to make this as a bitwise yeah, never mind then. Actually, that's an idea. I make a bitwise AND between the two. No, a bitwise OR between the two. And the result needs to be greater than 0. And that's it. If one of them is negative, the bitwise OR would be negative as well, because the sign bit is set. And if they are both 0, then it will also be... Yeah, that's... Ooh. I like this. Okay. Wins or losses. Greater 0. Ha! And we reduced it again to 2 operations. And this time it's actually valid. This is the kind of stuff I like. It was obvious. It's just bitwise OR instead of an addition. Makes sense. Okay. With that, we can do that. And the calculate score, yeah, we can drop that for now. It's just not implemented exception. I'm gonna do that sometime later. Comparison between the scores is there. Now we have to do the hard part again. That was just warm up. Finding the... Okay, I know this is gonna bother me later, so it's just... Wins... Wins and losses. Okay. Now, detecting the groups. What's the easiest way we can detect the different loops or groups of loops? I mean, it's easy enough. I can just take a note and check all its children to see if at any point I'm hitting myself again. If any of my children have a reference, or if any of my descendants have a direct reference to me as their child. But that's gonna cost me a lot of terms. Cost me a lot in terms of performance. What else could I do? Okay, what if I put on a marker of some kind? Like a marker, maybe all nodes start with, let's say, an integer value of 0. And I go through my entire tree at that point. Not tree, through my graph, starting at the root, and starting at the root I just set the marker to 1 just to indicate that this is now a node that was visited, and then when I hit a child that already has a value of above 0, that means this is now part of a group. But then I would have to go back the entire path. That means I would have to now that would be a recursive method that might go through a huge part of the entire tree. Or well, graph, not tree. Not the goal. What's a quick, easy way to do that? No, what's not a quick in terms of processing power and also memory. I guess I want to store them anyway as a separate. I mean, since I'm doubling it up, it's not really changing the big O in terms of complexity for memory. It's just ×2, just a constant. Doesn't feel good though, doubling the memory. What can I do? How do we... Okay, what if I start with a counter of 0 at the root? Instead of just passing on, going through the children and setting everything to 1, I set it to 1 plus my own value plus 1, other way around. So as we progress through the entire tree at that point still, or what looks like a tree, every layer would have an increasing score. Now that doesn't help me. I would need to, not just every layer, every node I visit increases the overall counter. That's more like it. So for every node we increase the counter. And when no, that doesn't help me either. I was hoping that I could calculate a distance or estimate it, but that's not. Just because the counter was increased through a side branch somewhere, I might have a massively increased counter even though my node is just 1 or 2 stops away. Doesn't help me either. How do I find all the loops without going through everything several times? Okay, maybe a different path. While I'm constructing the tree, I already know that certain nodes are visited again. So those are definitely... The nodes that I hit twice are definitely part of the loop. So this else branch here. If I'm hitting the node that I find is definitely part of a loop. Because there are now 2 different nodes that point to it. It's not, if it's just normal tree, just linear progression away from the root, then you would always have just one ancestor, one specific ancestor, parent specifically. But any number of child nodes. If I'm hitting a node again, that means that node I'm hitting now suddenly has 2 parents, and therefore must be part of a loop. That's the only case in which a loop is hit by more than is reachable by by more than one ancestor. One could be from outside the loop, and the other one from inside the loop, like that. So at least I can identify specific nodes that are part of a loop. And more specifically, they are candidates for being entry points into the loop, since, again, they have more than one parent. Now, the parents could both be part of the same loop, but if one of the parents is not part of the same group of nodes for the loop, then that parent is a normal node, or at least from a different loop. It's an outside loop, and therefore the node it points to is an entry. Right. And every node within that loop that, right now, I put those nodes I find that are duplicate, I put those in a separate structure. Let's just start simple. Let's just make a list. Node. Well, guaranteed loop nodes. Then let's add next node. So at this point we have the entire existing selection of nodes which we could iterate, and we have a list of nodes that are definitely part of a loop. They could all be part of different loops or the same loops. They could be entry points, or they could be standalone within the loop. They could even be exit points. I haven't considered that before. We have cases where the entry loop to, or the entry node into a loop could also be an exit loop at the same time. We shouldn't exclude that possibility. I'm pretty sure if I think about it a bit more, I would find some simplifications here because they couldn't happen in normal play, but I don't have the mind to think about that. Alright, so we've reduced things to a list of possible nodes. Let's just let this run for the 4x4. See how many nodes we can find. Okay, let's see. We have a total of 85 nodes. And wait. Oh, I made a mistake here. My bad. Right. Alright, so we have the nodes in total, but the values seem weird. We have 85 possible nodes, of which 67 are part of a loop. That seems... Can that work? I mean, I guess on this board there isn't much you can do in the beginning, and once they are both promoted, everything will be just a repeat of everything else. Okay, let's see. 1, 2, yeah. 4x4 grid. Yeah, so we have total of 8 spaces. Times 7. If both pieces are promoted, we already get 56 possible states. Right? Yeah. We have 8 possible positions. First one has 8 possibilities, the other then has 7 possibilities left over. Each node represents one state. So 56 in theory for that. And since with promoted pieces you can just always come back to one, that doesn't mean we have many loops. We have just majority of nodes is part of a loop, which is great. This is gonna make everything so smooth and fast. Oh yeah. So happy about this. Alright. Guess we'll now have to... Right. The process would now be go through that list of guaranteed loops, and for each of them figure out which nodes are part of its loop. And for every node we find that is part of its own loop, we can drop that from the list of guaranteed loop nodes. Make our life a bit easier. Like if there's a large loop in which just most of them are connected to, we can just drop everything else. Means let's just switch this from list to hash set. Who cares at this point? I don't. Honestly, I'm not sure I'm actually gonna bother optimizing this. Alright. We have the... Sorry, I'm not saying anything, I know. I'm just currently thinking about the process, because hash set is not ideal right now, but it's working. That's sort of... I need to get one single item from the hash set to process, and I should drop that from the hash set. But the hash set data structure isn't intended for that, so there's no direct method to retrieve one random item from inside the set that is dropped. I only know of the enumerator, which allows me to get the items in there. But that seems a bit overkill, but I don't know an alternative. So, guess we're gonna do this. As long as there are items in there, which we can't always assume. Like, there are constellations, usually boards that can be played on, that will not have any loops. So we shouldn't assume that we guarantee to start with one. And just first, yeah, let it get the enumerator, retrieve an item and drop it. We know there's gonna be at least one, and it's just gonna dispose the enumerator afterwards, so we can modify the hash set again, which would otherwise be a problem if I enumerate it. Once I get the enumerator, I can't actively change the hash set anymore. At least that's how I remember it. Maybe the hash set had some looser rules, but let's keep it like this. Again, it's kind of wasteful. Loop nodes. Then we can get loop nodes dot remove nodes. Wait. Do I have a method that I'm currently going through the IntelliSense, checking if there's no. No, I can't use any of those. Well, too bad. So, removing a single node. Now I have to iterate through its children until I find myself. Do I make this? Do I add this as a simple method in? You've done overachieved. In what sense? What have you achieved that has gone so overboard? Congrats, I guess. Yeah, let's just do recursion in here. Why make it complicated? Let's just get the basic down first. Public void find itself and descendants. Let's see. That means, okay, that might be the entry. Nah, let's make it simple. That's gonna be node. Gonna provide that from the outside by calling itself. Let's skip the nice outside method and the internal actual. If child nodes. Child nodes count less than 1, return false. Each child. You made an AI to play the game. Self-improving training an AI. And okay, 5,000 goal, 83,000 actual. Did your AI find a glitch or a bug, or did it just play normally and it's just possible to reach scores beyond what you initially assumed? I mean, the classic story is that you let an AI play the game and it finds exploits that you didn't know about. Both would be fun in their own way. Just misinterpreting your own possibilities in your game, or having an AI crack the game. It's good. I guess it's a good beta tester in that case. That was I child. Right. If attributes reference equals child and node, turn true. Otherwise, do I split this into depth first, breadth? That's too simple. I guess at this point. If reference equals then true. Otherwise, child dot and self and descendants node. Return true. Return false. Okay, so it did play fairly. Just with extreme precision. Yeah, aimbot, as you said. I mean, it is... Does it have an aimbot, or is it the aimbot at that point? Can it cheat in other ways? Like having knowledge that a normal player wouldn't get from the UI? Like having data about where certain goals will be, having full access to the entire map, predicting the enemy movement, stuff like that? Or does it get actually surprised by things? Size sense, blah 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 blah. Contain loop node and loop nodes. Loop nodes. Alright, so this algorithm gets through the entire stack and finds all the descendants. It's not pre-firing, it's only shooting at things that are actually visible or would be visible to a regular player as well. Alright. Well, I guess that means you suck at your own game. If you assume... What's that? 5/16 of the actual goal the AI reached. I mean, how did you get to the 5,000? You must have some basis for reaching that value. I would assume it's through playtesting yourself. Was it maybe an old score and from an old version and you never updated it in your mind? Okay, so you play tested and others play tested, human players, and that's around the highest the human players managed to get it, 5,000. And the AI managed to get 85. Well, okay, 83 something, but let's say 85. There's a bit of a gap here. How exactly did it do it? Okay, it was very good at aiming. How about the movement in general? Like, how does it... No, I guess that's not... No, well, if it works, it works. I'm in my loops, I'm in descendants, I'm in my loops. The goal was to find all the ones that are in here. And let's see, list, node, group. Let's say, make a new group. That's gonna start with me in it. And then gonna add that. This is gonna get the group. If child, then I am the hit itself. And that means I would need to put that in here. Group.add child. If my child finds me, well, the initial node in its descendants, it's also gonna be part of the loop. If it's itself having the main node as a child, it's not adding it to the group. Yeah, okay, this way it works. Right, this way I get the entire group in here. Now things get a bit more interesting. Let's drop this maybe, and then remove range. Wait, not group. Guaranteed group nodes dot remove. Yeah, I guess we're gonna do this. Each node and guaranteed group nodes dot remove node. You said your AI was training itself and improving. What basis does your AI have? Like, how does it work fundamentally? Is it deterministic? Like, is it a set of independent algorithms you came up with yourself and they're just very good at making quick decisions because they have faster reaction times and more precise aiming and movement? Or is it more of a black box like neural nets where you don't quite understand what it's doing? It learns after each run what it did right and wrong. How though? Like, okay, I guess the how doesn't matter too much, but yeah, I'm interested in what the basics is. Black box, or can you actually identify why it's so good? Without just observing. Like, can you look at the data and see this is where it's so good? Or this is a good strategy? So that means you could now learn from the AI to figure out better strategies to get higher scores yourself? Like, knowing how the AI does it, can you get better scores now as well? No, I don't mean observing what it does inside the game. I mean observing what it's thinking, so to speak. Like, can you step through and figure out exactly this part of the code is doing exactly this, and that is why it's doing this, and therefore it's this good? Or is it like a neural net where, okay, these values somehow make it do this decision, but I don't understand why it's making this decision? 50-50. Let's try this. And let's make a larger list, which is a list of nodes, groups, and then we can groups add group Alright, so have to get used to the new initializers. This is now taking care of one branch of the group, but those groups might themselves be interconnected. So in theory, I have later on this groups list several entries that might actually need to be merged. Post a link. Is it by any chance a link to itch for a working version, or? Yeah, sure, post it. Oh, do you have some nice graphs to demonstrate? Maybe instead of a list I do... Yeah, I have used so many hash sets already, why bother with anything else now? New hash set, group, whatever. What can I do here? Really? Hash set can be used with the connection. Okay. Twitch link. Oh. Wait, what is it doing here? Let's see. Chrome. Let's check out the link. Okay, I'm watching the video right now. Okay, the jerking is unexpected. Okay, a very precise aiming movement. I guess the moving towards us is to increase the speed, to make it faster to get to the target, destroy it faster. Yeah, it makes sense. So let me turn on the volume. Okay, let's move forward a bit. Okay, now we have some obstacles. Okay, now it got a bit stuck there. All right, yeah, I guess I can see now where the AI is beating out the humans. That level of precision and reaction time, that's gonna be hard to beat. And very disciplined positioning, at least in the beginning. Still that difference. I guess a pro player, like be really dedicated kind of player, I could probably get in the 5-digit range as well then. But I'm not sure if anyone... Would it be possible for a human to actually get close to the AI? How does it make the decisions for the upgrades? Is it also just learning? Making decisions randomly and seeing what works? Or did you give it a limit of these are the upgrades you should take beforehand? Okay, so it is learning the upgrades itself. Yeah. That's one scary enemy. But I guess you have a good tester for balancing, right? If it's learning the upgrades itself, figuring out which works. If you give it some wiggle room and see if it's how easily it's switching to a new upgrade, you can test how balanced they are, right? Like if it's always picking the same one, you know it's the best one, and if you make it slightly worse than another, and it's switching immediately, you know they are somewhat equally balanced. And if you nerf it and it's still not switching, then it probably needed to be nerfed, or the others need to be boosted. I guess that could be a bit difficult to determine why the AI is switching or not switching. Never mind. What to do? I switched to hash set because at this point, who cares about optimization anymore? Loops serve dummy. The hash set is there. What else do I want to do? What else do I want to do? Ah, right, I wanted to... And... because it's not demanding enough, let's go a bit further. We go through all the groups. Group set, and check if a node is in there. If... yeah, no, if group set contains node, then set node group set. Need to find better name. Listing. You made that without knowing, or don't tell me you've been vibe coding. Please tell me you've used an existing engine, some good tutorials, and some pre-made assets that you just had to modify with minimal coding and a lot of settings. If existing group sets contains node. Group set Group set. Yeah, no, let's set it to existing group set. That's fine. And actually, at that point, we can break. If it's a 0 fur, it's a null. Yes, sorry, null. If group set is not null, crap. Is null. Only if it's null. Sorry. Wrong way around. If it's null, just iterate through all the groups. See if any of them match. And if so, we have found an existing group we want to get into. If group set is null, but still not down here, then group set is gonna be a completely new group. Like that. And then we're gonna add... no. No, this is not the way. I made a weird decision here. What is the plan? Okay. I have my group. Alright, I have my group. And I made sure that I removed them from the nodes I need to check because I already have the group. And while doing that, I'm checking if I already have an existing group. And this is just a different branch within that group. And if it's not, then we're gonna add now. How do I get the group set? Can I optimize it? Can I okay, at least a bit of optimization, I guess? Nah, let's group set and add. I don't have an add range, right. Yeah, okay, then let's make it a bit more annoying. And we're gonna go through our group directly again. Group dot reach. Group set dot add node. Just to keep the logic a bit more on nose. Okay, so you did use a tool, but you didn't do it all in one go. So you do somewhat understand the code. You didn't write it in that sense, but you do understand the code that was written. Right? That's how I understand you right now? Okay. Well, can't say I'm happy about the AI use, but at least you're using that responsibly, so that I can live with. I mean, not that my opinion matters at all. If it makes you happy, if you get success from it, I guess it doesn't really matter how. Doesn't that kind of means you have an AI that wrote you an AI, right? How often does that happen, I wonder? How many AIs are out there right now that are written by AIs? And how many of those are written by AIs? How much vibe coding is going on in the big AI companies? That'd be an interesting statistic. Do they use their own AIs to help them write and modify the AIs? Or do they eternally have a ban on please don't code with this? I guess they would never tell the investors or the outside world. I think that's it. I should have. Okay, let's just see if it breaks. It broke. Stack Overflow. Cool. So I forgot to close it down somewhere. Where though? Oh, wait. The recursion works, of course, if I'm in my own loop. But I might have other loops that I'm branching off. Like, still part of the same overall group, but a different branch of looping that is maybe closed in itself, like an internal loop. And that can get stuck in itself. So, oh boy. Okay, let's do it the lazy way. Because at this point, who cares anymore? I just want to get it done. This was supposed to be a quick, simple project. The loops are killing me. I think the loops are the single biggest issue about the whole min-max right now. The whole system is suffering because of the loops. Maybe I should have just made a special rule that promotion isn't allowed. That way I would have definitive end states. Just a regular tree, nothing fancy, just classic, good old min-max. That would have been nice. But no, I had to pick checkers. Of course I had to have repeated states. Of course that needed to be legal. Of course I was too stubborn to just change it and stuck through it for God knows how many hours now. How do we call that? Visited nodes. Well, I guess that's something. Wait, as a hobby. Doesn't mean you wanted to make that game just for fun? And release it just as a hobby developer, so to speak? I see. Well, I have even less reason to complain in that case. Where's my mind going? We have the child nodes, we have the visited nodes. Now let's start here. Visited nodes start at this. Let's just make it straightforward. If visited nodes contains child. Continue. Okay, let's try again. What did I miss? Oh, right. New hash set. That's what the responsible developer would do. Not many people do. It didn't crash, so that's good. What does my groups actually contain? 41 groups. Okay, this is not correct. According to this, each group has... Yeah, that's not possible, so I definitely made an oopsie. Very big one. Yep, they do. I mean, sometimes it's obvious. If you see an slot game, it's very obvious in your face, but sometimes it isn't. In your case, I mean, I haven't played it, but the Twitch video I saw looked just like, yeah, I made a simple game. I wouldn't have thought it was AI, at least not from the video. What is... I'm adding myself to make sure I'm not... Okay, I'm starting at myself. I'm going through all my children. If the child was visited already, we can skip it. Wait, no, we can never visit ourselves, so I guess we can... Oh, this is not... I'm doing something wrong here. And I just can't see it. I really need to switch my time schedule. Nope, no, I'm sticking with it. Just give me a sip of water. Right. Let's just debug. Let's see, what do we have here? Group contains only one item, so that's already the issue. Alright, cool, so we know it's probably just the recursive method here, that's the issue. Let's see what's happening inside that's causing it to not find anything else. We know node itself, the node we are in right now, is part of a loop. If I didn't make any other mistake, that is a guarantee. So this needs to find something else. Let's put some... let's make some returns in here. The different options, let's put them in. Okay, visited nodes. At this point we have 5 nodes visited. And contains child. So that one is exhausted already. We can skip it, and that's it. Okay, no. This has 1 child. And this has 2 children. 3 and 4. So it's branching off. None of them have... Nah, that doesn't make sense. Nice. Did you just start out learning coding and stuff? Or did you already have some experience from some other time that you're just rediscovering now? Okay, a year into development, and that's the result. That's pretty good. I wouldn't be able to make that, I think. And I'm now decades into it, so well done. Maybe that says more about me than you. No. Okay. Where am I wrong here? What is it? What am I overlooking? What am I missing? Let's ignore the group. That doesn't matter. Visited nodes. This means we are never... Is it... I mean, that shouldn't matter. This should not matter. It does matter. Why? I don't think your ceiling is lower. I really don't think so. The quote-unquote professional coding that I do, it's not that complicated. There's specialized knowledge, yeah, but the actual programming is usually pretty simple. Like, the complexity is pretty it's not really there. That happens sometimes, but then you have an entire team to discuss things with. You need to discuss it with the entire team, because you can't just make something new and complicated without involving the others. Then again, I'm not in an industry with high performance. We're shipping out billions of products each day and whatever. I guess there are different... different layers. The higher you go up, the more is expected of you. But the area where I work in is pretty lax. I don't think game engines are out of your realm. I mean, you have a game. That game uses an engine. Therefore, you have a game engine. So you have an understanding of basics of a game engine. Difference is just that some proprietary engines have some more options and name things differently, and maybe have some very, very fancy stuff inside to get everything running in 4K with millions of polygons, but the basics are always there. And the other engines do the same, it's just they name it differently and You use it slightly differently, but the basics are always the same. But you would have to relearn it anyway if you ever switch an engine. That's more learning a specific framework. That's not learning about game engines. I don't think you would have an issue learning that. I mean, I haven't... Okay, maybe I shouldn't say that since I haven't really used one of them. I did use Unity back in the day. I think the first and only project I ever managed to work on that I ever did in Unity was was like a racing game. You were basically a hamster in a hamster ball, a transparent one, and you were running in with that hamster ball through an obstacle course on a beach. Well, an oversized hamster ball. You were about as big as the palm trees. And the fun was that the gravity was relatively low, so every little bump, every little dune you came across would just send you flying, and you had a really nice, satisfying arc going down. That was fun. And I did that when I basically had no idea about anything. So you now, with actual knowledge on stuff, probably would be capable of making that stuff. Don't sell yourself short. If you can do stuff like what I just saw, like fully finished package, especially that, just upload it to a website where I can just use this. Not a demo version that works on your PC, but actually it's complete here, the full package. You definitely can manage something in an engine, something else. Oh, why did this... Okay, this shouldn't have made a difference. It did though. I'm not sure why. Let's not think about it anymore. Getting tired as is. Let's just see what happens if I let this play out now. How many? Okay, 12 groups. That's still wrong. So we have one group with 40 and 11 groups with 1, which is still wrong. A racing manager. Okay, so you didn't race yourself, but you raced the computer to race for you? Ah, right. Okay, I see. I can see the vision. And you can always decide to just have the AI race for fun, but the actual game uses stats behind that you determine. And the racing manager, you don't actually need to display any race, right? If the AI is goofy and doesn't properly drive along the track, that doesn't matter then. Or you could switch gears and say if the cars get too fast for the track, you change to the track. What was the game? Something, was it F-Zero? Once we have the flying cars on these three-dimensional tracks, where everything is meant to be very fast and over-the-top sci-fi. Unless, of course, you want to go realistic. In that case, maybe the cars shouldn't be too fast. You know what? I'm telling you how to do your game. That's not correct. That's... Ignore me. And why am I... Wait, that worked? That works. Okay, I can't believe the 40 in one group. This is not possible. So I'm still messing up. Okay, first of all, have I made the right decision here? Loop nodes. I always check the state. If it points to an existing one, that is a guaranteed loop. Yeah, that holds true. That is correct. Correct loop nodes has to be correct. Well, it's less about not wanting to tip on your toes. Oh no, what's the thing? Step on your foot? Step on your... Step on your toes, right? That's the saying. It's more about it's your idea, and if I just talk about stuff that I think, it's not your idea anymore, right? I'm boxing you into what you're thinking then. You might have an idea and I'm giving you some other idea, and suddenly you can't think of your original idea because you're focused on the thing I said. I'm limiting where you're going. Especially you said you dropped it, doesn't mean you don't start it again. And if you're at that early stage where you're not sure how you want to progress with that, I don't want to limit your vision, so to speak. That sounds way too extra. But you get what I mean, I think. Okay, let's just check the different values here. Do those check out? Group 8 entries. Seems good. 16, 20, 16. This one didn't work. Let's try that. And we step in here and here and here and here. Okay, this one, it is a chat. What? Wait, how? Our loop node doesn't have any children? How can I have a loop node if it doesn't have... Oh. Oh, of course. Well, I'm glad it didn't ruin anything, so... There you have my input then. And yeah, I made a mistake. It's not a guaranteed. It just means I have two parents. That's why I have so many groups with only one entry. It is not a guaranteed. It's a possibility. These are candidates. So guaranteed loop nodes, it's potential loop nodes. Okay, so in any loop, there's gonna be at least one node that has two parents. Has to be. I need to somehow be able to enter the loop. And I know the root node is absolutely unique because that's the initial state of the board with all pieces unpromoted in the initial positions. The first couple of nodes cannot be looped too, though that is safe. So if I have possibility for loops that do not start at the very top, I need to have some way to enter those loops. Otherwise, they wouldn't exist. So they have definitely two parents, minimum. But two parents itself doesn't qualify as a loop node because I can point to the same state as another node, and it's just simply the same end state, which is linearly going down to an end state, which this one does. Yeah, possible potential loop nodes. Candidate loop node. So it's candidate loop node and let's put that in here. That back in here, candidate loop node like that. If group count less than 2, continue. Okay, in that case, the candidate turned out to be nothing. It's not part of the loop. This is gonna check for a loop, but it's not always going to find one because, yeah, nothing happens. Actually, wait, I made this Boolean. And I only return true if I actually find one, then I can simplify this. Not that if continue. Right, so this should work a bit better now. So we can drop these, continue. Now groups contains only one group with 40 nodes. Okay, scores everywhere 0, that's correct. Okay, that means we have a total of 85 nodes, 40 of which are combined in one large group. Actually, let's make a little check here. How many does it belong to, this one or this one? Create a new group here. And there we add to it 2, 3, 4, 5, 6. Alright, so create the group once, 10 more. So that means we have 10 interwoven loops, which is interesting. That's definitely a big tree. I'm not gonna... Maybe I should write... No, that's going too far. I was thinking about making a visualizer, but if it's not a tree, but a graph, that's gonna be a pain to do. Let's not do that. Alright, so we have theoretically the groups now. And it's only taking massive amounts of resources. And it's potentially not working. Yay. Okay. Next steps would be calculating the scores. Easy enough for an end state. Now I should... So next would be finding out which nodes in which group refer to the entry points and which nodes lead to the exits. Let's pull up the... Let's get the graph back out. Where is the screen share? All right. So we have the isolation of the group, in theory. And actually, I think... Do we need this part? No, we don't need this part anymore. And we actually switched that around. Let's drop this part down here for now. Those were the exits. Can drop those. Alright, how to identify the... Actually, what do I... Okay, that's the red one. Don't want the red. Actually, let's keep the red. Okay, the exits are pretty straightforward. I just have to go through the entire group and then pick out which nodes have a child, or at least one child, that is not part of its own group. So, in this case, these three. Entry points is a bit more problematic. In theory, I would have to go through the entire tree again and check for every single node if one of its children is part of any of the groups without itself being part of that group. In which case, that specific child is an entry point to the group. So each group would have the nodes in total, the subgroup that is the entry points, subgroup that is the exit points. Those can overlap. And with that, I would have the fundamentals to calculate a score. Let's see, how did I do that? I think now outside I just used basic rules to start from the leaves, going up with the new score. Instead of a straight up ratio, we score up the actual amounts of wins and losses just to have more information. Already have the score struct, that's not an issue. And once I hit a node that I would go through this recursively. Yeah, no, that's fine. Go through the entire tree recursively, hit a leaf. I can calculate the base score, win or loss. Then step back to the top on the recursion, calculate based on that. And on every step, check first, am I part of a loop? If I'm part of the loop, I need to calculate the score for that loop, but I need to have the score for... Actually, if that's part of a loop, then I can skip that one and go back up. Okay, so we have multi-pass system. I would always start at the root, recursively go down, try to calculate the score. If that is not possible yet, I would at least have a list of groups that I need to calculate. Can that actually cause issues? I didn't think about this scenario before. Right now my algorithm would... I would calculate, of course, all the leaves, that's straightforward. And whenever I hit a node that's part of a loop, I would need to calculate the loop. To calculate the content of the loop, I need to calculate the score for every single exit node, or need to have the direct score for every single exit node. And those would get the exit scores through the normal method. What if those are themselves part of a loop, but just an adjacent loop that is not directly part of the same group, which can happen? I would need to wait for that loop. Can that loop recur? No, it can't. If it were a loop that also points back to itself, I wouldn't be able to calculate the score, but in that case the two would merge into one larger group, so that's not an issue. Okay, I can't have in a situation where a loop cannot be calculated because it's waiting on another loop that is then pointing to itself. No deadlock here. Good. Then... if I go through this once, I should be able to calculate everything up to the first loops. And not every loop might be able to calculate its score, but at least one of the loops, if any exist, will have every single necessary score on all its exit points. So I can calculate the values within that one loop. And after that's done, I can go back recursively, go down, and try to calculate more. So I would always calculate score in the tree, recursively, as far as possible. Then calculate all the loops where possible. Then calculate the tree again, then the loops again, then back and forth and back and forth. Repeat the whole process until at some point I'm at the very top and I have the score of the root, at which point I can stop. Which sounds so incredibly wasteful. Okay, let's see, how do we simplify this? I can go to the leaves, sure. And once I hit one of the leaves, it's done. Recursively, and then I go back up. Actually, it's done. And it's going back up recursively. This one is done. And go back up recursively, and notice my node that I'm checking right now is part of the loop. Oh, wait, how would I do the recursion? I would first need to get the score for all its children, right? So I would actually first check this node after this is done. And this node is part of a loop, so I have to stop at this point. Yeah, if I do that, then I wouldn't be able to get a result at any point. Oh wait, this would calculate score recursively, right? I shouldn't check if it's a part of the loop. I need to Let's go down. I need to find the next node that should be calculated, which would go down all the way here first. That would be a leave node. Calculate done. Go back up. Calculate possible done. Go back up. Calculate recursion. Going down here. Going down here. Checking this one. Scores are calculated. Endpoint there. Done. And then the first loop. Now I need to... At which point in this recursive traversal do I... Oh wait, no, that's the point. At this point when I follow the recursive method downwards, and then at each endpoint where I stop, I check, is it a leaf? Then yes, get the score, fixed value. If it's not a leaf, then check if it's part of a loop. If not, see if you can calculate the score, which we can do here, and then go back up. And then it would first get the children, of course, because that's necessary. Go down, down, down. It's a leaf, it's fine. Check the normal node, it's not having any other children, calculates the score, it's not part of the loop, it's fine. Go back up. Try to go down here, go down there. First child is done, second child is done, third child. And now would go down the recursion. If it was the path, you would have ended up right where you started again. So I don't think it is. Sorry to hear that, by the way. That's, if that wasn't a joke. If it was a joke, ignore me. Now at this point, it's... I'll go down here. Is it a leaf node? No. Is it a normal node outside of the loop? Yes. Try to calculate the score. Back up. Down all the way. I need to calculate the score. It's a leaf node. Can calculate. It's a normal node. No, it's a normal node. That doesn't have a score. Is it part of a loop? Nope. We can calculate the score. No wait, that's a recursion. I should first... I go first through the children, try to calculate the score, then through the parent to myself. So... let's go down to the child. Leave nodes, check. Normal node outside the loop, check. Children first, go down, go down. And because I'm always going recursion first, I would get stuck in my own loop. So that's not an option. First I need to check if it's part of... Is it part of a loop? No, then try to calculate. If I do it that way, I would have to start up here already. No, that's also not an option. Downwards and always stop unless when a child has is either a leaf or has a score. It's a leaf. Stop here. We already made the decision to go down here, so the recursion didn't stop for the loops. That doesn't help. No, I do start earlier. Oh. Check the node. Is it a leaf node? No. Alright, so is it part of a loop? Doesn't matter. I can't recursively traverse this graph because I'm always getting stuck on myself. Unless I keep track again of which nodes I already visited. Wait. With my system I had now the dictionary, which contains all nodes. Basically I have a list of all the nodes, a linear list. I don't need to traverse a tree recursively. I just can iterate the entire list. And check which ones are leaves. I mean, at this point, I can make a new set to keep track of what I've already processed, or I can just use the existing dictionary and just drop them, I guess. Go through the dictionary, check for nodes that are leaves. So nodes that I can calculate a score for, which would be leaves in this case. And remove them. But then I'm at the start again where I just constantly repeat looking for nodes to process and remove them and look for them and remove them. With the recursive method, which I can't do, I might have a way to optimize it because I already know which loops to check next and which nodes I can continue with. Maybe it would be better to have a two-way connection, so children have a link to their parent as well. If I then just... No, that's not helping either. Where is it? I can still identify the leaves. Actually, I could just store them beforehand and then grow from the leaves, which I know have correct values. If I were to start at a leaf, could just go, leaf is done, go to next. Or maybe, no, I would start with only the list of leaves, process all of the leaves, basically breadth first, plus two-way connection. And for every leaf I check off, I then get the parent node or nodes, in case there are several. And that's the next list of nodes I would need to process. For each of them I then check if it's part of a group. If yes, put that group in a queue for queue groups to be processed. And if not, try to process that. No, if not, then see if we can, if it's not part of a loop. If it's part of the loop, put the loop in a queue. If it's not part of a loop, try to see if the score can be calculated, which will not always be the case. But if it can, cross it off and put its parent as the next in the list. And then do that for the other ones as well. Is it part of the loop? Nope, nothing happens here. Put its parents in the list. Put in, is it part of the group? Yes, this one was part of the group, so we put the group in a queue. And so now we have, after this is done, we have a new list of nodes to check, which are these two, and we have a group. So first, I check the groups in the queue, which is only this one. Are all the exit codes or exit nodes defined already? If not, we leave the group in the queue and continue with the normal nodes. We see the loop is in queue. These are all we have the group in the queue because they're all part of a group. And that leaves us with no nodes for the next operation. But that also means we have to have all the exit nodes for this group covered. If there are no more nodes to discover except for loop nodes, that means every single loop has to have all its exits covered. At least one group has to, at least. Which would be this one. That means this group cannot be processed because all of its exit nodes are defined. That algorithm can happen. All the nodes inside are taken care of. And that means the two entry nodes are now defined as well, and they get added to the list for the next iteration. You know, that could work. But I still have the issue with the loops later on. The same issue I have right now if I'm going downwards. Because of the loops, I might end up, even if I'm just following the parents. Like it's just the other way around, but it's still a loop. So that's not helping. Yeah, I guess I'll just do it the straightforward way. Use the list of nodes I already have with the dictionary and just make a multiple passes over it. Just make one pass, figure out which nodes can be calculated, either because they are leaves or because all of their children have defined scores. And they themselves are not part of a group. With the groups, same reason. They themselves are not part of a group, but if there are no nodes to be found... Wait, I get the list of default nodes. I go through it, find all the nodes that can be clearly scored. Because they are not part of a loop, and all the children have their scores. Those get properly calculated and then dropped from that entire list, just to make processing a bit faster in the future. Hopefully this will actually work quite well, because in theory at least, we should over time get closer and closer to the root, which means less and less nodes. Exponentially reduce it. And when we get a pass where no nodes could be calculated, but we are still with a full dictionary, that means we now try to find all the groups, now all the nodes that have all their children fully defined, but are just dropped because they are part of a group. Those groups get all queued up and processed, at least if they can be. All the exit nodes are covered, one of them will be at least. That would then later on leave 2 nodes defined for node process. Yeah, okay, so that's gonna be the way to handle it next time. It's gonna be next time because I am spent. I think I made progress. Quite happy with it. I'm gonna continue next time with more coding. Have a lovely Sunday. Till next time. Bye.